Welcome to Introducing Industrial Edge. My name is Andrew Gracie. I am one of the product managers in the Cloud Native Edge business unit.
Hi, I'm Nicolas Belouin, and I am a software engineer in the SUSE Edge business unit.
Today we're going to be talking about Edge, especially when we're talking about Edge in an industrial sense. There's a lot of different terms that are kind of used for the same change and the same pivot in the industrial side of the world. It could be like digital transformation, digitalization, um, the IT, OT coming together, have a lot of things that you might call kind of this shift in the industry by. Um, so when we're talking about edge at SUSE, we are typically talking about a class of computing where we are sharing a lot of the same constraints. So a lot of edge computing is really geared towards moving your compute and moving especially the control loops that you have on premise, moving basically shrinking that control loop so that everything kind of sits on premise. And that means that you have to move all of your compute on premise as well and not have all of your data be sent up, say, to Amazon or Google to be processed and then pulled back down. That takes a lot of time and it can be very expensive to do. So when we're moving all the compute to the physical edge locations, we run into a bunch of different challenges. So the first one that we see a lot is that there's a lack of consistent platform. Uh, Historically, you would have had to hire engineers to deal with your core, you would have had to hire engineers to deal with your cloud, and you would have also had to hire a different set of engineers to deal with the edge. So with Kubernetes and with more importantly, the um, containerization of all of your applications, you're able to hire the same engineers and use the same skill sets across all of these different platforms. Um, there are also concerns about security, privacy, and compliance, especially in industries where that is important. Because at the edge, we're typically dealing with personally identifiable information. We're dealing with, like, say, healthcare records. We're dealing with, honestly, just things that you don't want somebody to have access to that they shouldn't. Um, and then lastly, just we're dealing with a lot of different types of different data, a lot of different types of compute systems. And just the complexity and the breadth of those use cases can make it very challenging to build a platform for. Um, yeah. So typically when we're talking about edge, we're talking about a very large amount of scale. Um, thousands of thousands of locations, thousands of Kubernetes nodes, tens of thousands of devices, and honestly, these could all be like 10,000 nodes, 100,000 nodes, and millions of devices for some of our customers. So, how do you onboard that? How do you manage that? How do you make sure that everything's actually up to date and all secured? It can be very tricky to do. Um, yeah. Sorry, I didn't realize that was a build. Uh, um, so the thing that we're looking at, at providing to our customers and our users is simplifying your operations, primarily by reducing the complexity of the platform that we provide. Um, we're doing this with onboarding, right? We want to make sure that you don't have to have somebody have a technician sent on site for every single device that you set up. Um, both the Kubernetes nodes and the devices that are connected to them. Everything should be remotely managed, both the clusters and the upgrades. The workloads should be remotely managed. Everything should be secured. We do have New Vector as the underlying security piece, and that gives us a very good security footprint. I know that there are several talks about that this week, so definitely go check those out. And lastly, observability. need to be able to monitor and get access to logs, so that again, so you don't have to send somebody on site. Um, yeah. So this is our platform in a box. On the bottom, you can see that we've got a couple different ways that we can do onboarding logistics. Sleep Micro is obviously the underlying operating system for all of this. For the orchestration, you get RK2, K3S, and above that, you get all of the different pieces of the stack. So I'm not going to go through those on in this presentation again. There's a lot of presentations this week. The one that we're talking about today is ACRI up on the top right. So Industrial Internet of Things, device man, and specifically looking at the device management of all of those IoT devices.
So now let me introduce you Acri. So Acri is a CNCF sandbox project. It aims to tackle the device discovery issue by leveraging the device plugin system of Kubernetes. So Acri is a Rust project donated to CNCF in 2021. And it's hosted on GitHub, obviously. And this is a very modular system. Enables it can enables high availability for devices that can be reached by multiple nodes. It can allow to work in a plug and play fashion, so for all your devices. And obviously, this works for device directly plugged to the nodes or network based devices. And well, it's basically you write a configuration that shows what device you want to discover and what kind of workload you want to launch for this device, and then Acri do everything to make this work. So yeah.
Yeah, so when adopting a new platform, some of the risks, we've identified a few different risks that that our users typically are trying to avoid. So the first one, relatively obvious, setting up devices can cost too much time, right? Every single device that you have to set up and configure, that is some, and if you have to do that manually, that's somebody sitting there doing the little configuration. So if you're dealing with 10,000, 100,000 devices, that can add up very, very quickly. So we fixed that by allowing for configurations to be validated in a lab and then rolled out globally. Right? You don't have to sit there and configure every single one individually. Secondly, mistakes can be made on the configuration when you're configuring everything all the time, especially if you have if it's a manual process. So we mitigate that by automating the discovery and the scheduling of a workload against the device, so that way you can minimize the human error. And then lastly, one thing that we see frequently is that when we're talking about IT and OT and digital transformation and right, combining those two, historically you would have had a couple different teams that each had very specific um, roles and responsibilities. And historically they didn't talk well to each other. So today they still probably don't talk well to each other in a lot of places. Um, so we can help fix that by putting everything in a single platform, so that you get a clean demarcation between responsibilities, but you're able to uh, have more cooperation across teams and across those boundaries.
Yeah, so as I said before, Acri is a modular system. So one of the major set of components in Acri is, well, the discovery handlers. These are the components that, well, talks to the device themselves to discover them, to filter them, so that when you input a configuration, it outputs the right devices. Uh, Acri comes preloaded with a non-VIF, an OPC UA, and UDEV for, well, local locally plugged in devices, discovery handlers. So, but it can be expanded to support pretty much, well, anything you can think of just by spawning an additional discovery handler. So you can imagine anything from things like Zigbee, Modbus, MQTT, or ZeroConf, or, well, pretty much anything. And one important thing is, while Acri is in Rust, discovery handlers are not tied to this, can be written in any language that can do gRPC. So if your protocol only has a SDK for a specific language that also have gRPC, you can do that discovery handler in that language. Uh, and also, discovery handlers don't necessarily have to implement the full protocol. They just need to be able to discover and filter the devices. So they don't need to know everything about how the device works or what it does. So, for example, if we take the OnVIF device discovery handler, it doesn't need to implement the OnVIF profiles or know what kind of codec is MP4 or anything. It just have to be able to detect an OnVIF camera or device and say, okay, it matched that configuration that I've been asked to look for. Then let's go to the architecture of Acri itself. So, uh, Acri is based around custom resource definitions. Uh, there are two, in fact, the configuration and the instances. So, I'll to make it simple, I'll follow what happens when you create a configuration and apply it to your cluster. So when you apply the configuration, that is simply it contains what device you want to discover and what workload to trigger when devices are discovered. So the agent picked the configuration and uh, send uh, well the characteristics of the device you want to the matching discovery handler. So if you say you want to discover an OnVIF camera, it will send this to the OnVIF discovery handler that will then send back to the agent the list of devices it has discovered. And it can discover them any way it wants. So it's kind of uh, completely up to the discovery handler what it does there. So then the agent will create an instance per device that got discovered. And this instance will then be, well, picked by the controller that will then, for each instance, create the matching workload. So the workload currently can be a job or a pod. And, well, it will create that workload with all the needed information so that it will go on the right node, and then the agent can use the device plugin architecture to give everything the workload might need to contact the device itself. So as you can see, you have one device handler per protocol you want to support, and so you can add or remove discovery handlers quite easily. Uh, well, I guess it can be time for the demo.
Yeah, yeah. Let's show a demo. Awesome. Let's see what kind of example of what we just showed. And I just realized I need to adjust my zoom real fast because that is probably not viewable on the screen share. Um, Okay, so what we've got set up is um, is what we call kind of the robot arm demo, where we are able to play rock paper scissors. That I went a little too fast there. Paper scissors. There we go. And you can play rock paper scissors against the computer. And hey, cool. I picked up that I did scissors. The AIML model is not the best, but the underlying the piece that we're actually demoing is good. If you happen to be on site, we will be showing this on site at SUSECon. If not, we will hopefully have a demo available on YouTube in the not too distant future of kind of what this actually looks like in person. But the important part for today is that we set up Akri to have, and I need to refresh because I installed all this stuff before it refreshed. There we go. We set up a couple different configurations um, with basically we set up discoveries for a camera, for the display, and for the actual robot arm itself, which I don't have on location when we're recording this. Um, but you can see that in the UDEV camera configuration, the way this works is that we are looking for devices that match the UDEV rule of the kernel being video zero. This could be a regex or some other type of way that you can make this a little bit more generic. I just locked it down because I know which camera I'm attaching, and again, it makes for a little bit cleaner demo. But it can be much more flexible than I'm showing at the moment. And then so for every time I see a video zero across my 3 node cluster, it will go and run this pod spec where I have a couple different containers in it, and we'll see that happen in just a moment. Similarly, I have the same thing but for a display. That's how we actually get this loop back. This is actually coming off the HDMI of the device of the Kubernetes node, and you can what's in, and so we're actually playing this like on the node. If I hooked up like a real physical display, I would see it on that display as well. Um, so it looks for something with the DRM subsystem that is connected, and then runs a container with X11 and a container with Firefox to play the game. Um, And then, yeah, lastly, if I did have the robot arm, it would look for a TTY device because it's plugged in via a serial connection. Um, and actually, yeah, you can see here the regex that's being used. And that would actually then run the control system for that arm that listens for messages on the message bus. So each of those, because I have both a camera device and a display device plugged in at the moment, we actually can see these instances being recognized. So if I'm going to reach over, unplug the camera and then plug it back in, you can see that getting removed, and then it will be discovered again in just a moment once it reconciles. There we go. You can see that it came back in, and it did change the node that it was saying that it was available on. And then also in that, we can see that the pods themselves get rescheduled. And this crash loop back off is because I've got a race condition and it will reconcile. There we go. Because it has to wait for the frame buffer to fill up. Um, Yeah. So I can do that for both the camera, for the display, basically when we're talking about things being plugged in, anything can be plugged into any of the 3 nodes that I have available, and the right workload for them will be um, attached and run. So it makes it for a very flexible system that where if somebody say you have a node go down, you lose the actual Kubernetes node. You spin up another one, you plug everything back into it, and you're back online. You don't have to sit there and reconfigure anything. You don't have to sit there and like make sure everything got plugged into the right place. As long as you're able to detect what gets plugged in where, you can schedule against it very easily. Um, is there anything you would like to kind of note with the demo? Things to call out, or
Well, there's the only thing we can add to this is that we only schedule pod here, but we can also schedule job, of course. And if we had multiple cameras plugged, they will all trigger a new workload in the configuration we have there.
okay, so yeah, so that's basically the demo. Um, I think, yeah, on to what do we have next? Yeah, so what's coming up? So at the moment, excuse me, at the moment, we are in this whole stack is available for tech preview. We are looking at a GA release of later this summer, early fall timeline. Uh, one And then we're also working on additional protocols, Zigbee, MDNS, Config, Bonjour, Vahi, like that whole stack with all of its variants is something that we're looking at next. Modbus, both the TCP and serial varieties, are things that we're looking at building the right uh, connectors for, the right discovery handlers, along with MQTT. That way, say, um, yeah, we're looking at exactly how that would work, but being able to see uh, devices kind of come up on it on the other side of the MQTT bus and the schedule, basically the event sync for that is something that we're looking at as well. We will be building a Ranger extension to help you visualize and manage the configuration of all of these pieces. Then we're looking at the couple different workloads. So a virtual machine being able to be scheduled. This would allow for, like, especially in the industrial space, there's a lot of places where you still have to use like an old x86, 32-bit x86, Windows XP uh, uh, machine, because that is what still has the driver for the piece of hardware that you're actually working with. Um, so we definitely see that there's a need to run virtual machines as the workload that gets spun up instead of just like a normal Linux pod, because you can't port that over. Um, then we're also looking at human interface workloads. So like I just demoed, being able to show a screen, also be able to do like a touchpad or other thing like that. That's going to be especially important for like point of service systems, but also for like wallboards where you're showing like state of the entire system, like in a factory, right? Being able to show kind of health of the whole system as a whole, right? We're going to be adding in the ability to set up more complex rule sets. Right now, it is a workload per device, but we see that there's a lot of value in being able to say a workload per a couple devices, right? So a couple different devices. So again, take the point of service system as an example. You might want to only schedule a pod against a system that has a display, an input device, a barcode scanner, uh, a thing that measures weight. It's early on a Wednesday. Um, a scale. There we go. Right, and make sure that all those pieces are actually detected and available before you spin up the workload, so that you can actually attach to all of those at once. Um, We also are working on a way to do credential pass through, because a lot of the devices that you'll be connecting to, like take OnVIF for example, will will be password protected. And so you need to have a way that you can actually get that password before even starting to detect or schedule against. So, and then lastly, one of the things that we're working on is service mesh expansion. This is a little bit farther in the future, but the ability to one of the things in our stack is we're going to be looking at a service mesh and allowing that, and basically having that be a default part of the edge stack. And we want to help build a way where you can actually reach out to devices that aren't running Kubernetes, shouldn't be running Kubernetes, right? Maybe it's a system on chip with, say, you're running like an ESP32 or something older. You would be able to actually extend the service mesh out and take advantage of all the um, and make it look like your workload was inside your Kubernetes cluster, so you can take advantage of the DNS lookups, have everything be under like cluster.local, um, or and also be able to take advantage of the MDNS portion of that, so everything stays secure across that cluster boundary. Yeah, and with that, I think. Thank you. And we should have a little bit of time for Q&A. I think we're doing Q&A on site for
Yeah.
people watching. I was hoping we are, so that comment didn't sound out of place. But yeah, thank you.